Today we're excited to introduce the grand final of our SQL training program at Data Insights. Over the past few weeks, you've been honing your SQL skills through our comprehensive articles, from basic queries to advanced database management. You've tackled it all. Now it's time to put all that knowledge to the test with a practical case study that isn't just any test, it's a real world scenario that will challenge how you apply everything you've learned. Our case study revolves around a fictional company, which in our case is a library that needs your expertise to analyze their data and provide actionable insights. You'll find all the necessary details and data sets in the description box. Your task is to query the data, generate reports, and present your findings. Let's get started. So we are going to be working with the SQL Workbench. You will find a link in the practical case documents, which will show you step by step how to install MySQL and what to do. So we are going to start with the first question, which is to create a database named library. So in order to do that, we will write create database library, and we are going to add the semicolon sign. Just to precise that SQL is not a sensitive programming language, which means that you can either write in upper or lower letters. That has no difference for the SQL management system. So to execute this query, we are going to either press Control and Enter, or the thunder right there. So we have now the database library is created and it contains tables, but for now we have zero tables in it. The database, sorry, is empty. Now that our database is created, we are going to pass to the second question, which is to create the tables in the database. The tables we have are books, authors, loans, and borrowers. Just to explain the case study we have, it revolves around managing a library's loan system, which means that you will be responsible for tracking loan and return dates, ensuring that books are returned on time, and analyzing borrowing patterns. So, in order to create the tables in the database, we should use the database. So we are going to write use library, which means that we are all the operations that we are going to do after that are going to be stocked in the library in the database named library. Now we are going to pass to create the tables starting from the first one. The first one will be we can either write all the commands one after one, or we can delete each command and rewrite the new command from zero. From my case, I prefer to delete them and write them all newly. I'm going to copy the command to create the table authors, which has an ID, which would be a string, the last name string, first name string, and birth date that has um a type as a date. The ID will be a varchar. I will be explaining the difference between varchar and char later, which is a very, very important difference that everyone should know. We will say, for example, varchar 255, and the ID is a primary key, which means that we each author is identified by one unique ID. The ID should the same ID could not be duplicated. Two authors could not have the same ID, which means that the ID is really, really like something that you can identify each author of it. So, so now we have all the table authors, which is created with the birth dates and all. We're going to uh, create the table borrowers, which has exactly the same types, the same identifiers as the author's table. The borrowers here are the ones who borrow book. We have exactly the same queries to write, just to we are going just to modify the table's name. In order to execute this query, we are going to put the cursor in the front of in the top of the query, and we are going to press Control. I don't know if it's said right. Control Enter. Now we have the borrowers table, which is also created. We are going to create the ones that are a little bit complicated. In the creation, because we are going to specify the primary keys and the foreign keys. So in this case, the books, the ID of the book, which is a varchar as a primary key, the title varchar 250, and the author ID. The author ID is a foreign key because it's reference an ID that is located in another table, which is authors in our case. So the author ID would have the values of the of the ID which is located in the authors table. Author ID varchar and publication year, that we will just simply write it as an int without further complications, and the genre as varchar 250. Now it's the time to specify the fact that we have. So we are going to write the constraint, which is the fact that author ID is a foreign key, and each value that will author ID take it will initially be in the author's table, which means that it will be necessarily an value from the ID column in the author's table. Now we finish the books table with its creation, and we are going to execute the query as always. Now, once we have the table books created, we are going to create the final table, which is loans, that has the ID, the book ID, borrower ID, loan dates, and return dates. The loans table has also a foreign key, which is the book ID, and another foreign key, which is the borrower ID. The loan dates and the return dates are just normal dates with the type dates. We are going to write it right here, loan date as a date, and return date as a date. Return date as a date. Here we have the foreign key. We have two foreign keys, the book ID, which refers to the ID in the books table, foreign key book ID, references books ID, which means that's the in the table loans, the book ID all its values are the values that are contained in the column ID of the books table. That's the meaning of the foreign keys. And that's the foreign key uh, lets us do the link between tables. So if ex for example I want infor informations detailed informations about books, I am going to link the tables uh, with just a simple join. That's why the foreign keys are used. Now we created the loans in the database, and with that we are going to uh, to pass to the third question, which is to populate the tables with the scripts already given in the description. I'm going to give you uh, text document that contains some insert queries, some insert comments that you will run directly in the database, and you will have some data which is inserted directly into your tables in the library database. You, you just have to copy the the queries that are in the documents and execute each one of them in order to have the uh, data in each table. So now we are going to uh, execute this all. Hit control. It's done. Now the data we have is already inserted. If we try to look closer into our tables to look if the to verify if the data is inserted or not into the authors and all the tables, we can select uh, data from one table, just a random table. So we are going to do select star from books. This could be the fourth question, and it's also a verification to see if all the data is inserted to our tables. So as we can see, we have data that is inserted with all the ID, title, author ID, genre, and publication year. Now we are going to pass to the fifth question, yes, that says display books published after the year 2010. So we are going to display the books that have the publication year, which is more than 2010. We are going to use the superior sign, 2010. Select at one from books where the publication year is superior from 2010. As you can see, we didn't have anyone that is published after 2010. If you want the ones that are published before 2010, we are going to use the inferior sign. And here we have all the books. All the books in our database are published before 2010. This is used. So now we are going to pass to the sixth question, which says display all the books written by Victor Hugo. In order to do that, we need the information of the books that are written by an author. We have in the table books just the ID of the author, but we want the name of the author identified by the name Victor Hugo. So uh, the the only thing to do is to join two tables, the books because it contains all the information about the books that we want, and the table authors that contains the name of the author we want, which is Victor Hugo in this case. So we are going to select start from books, join authors. The join key here is the ID, the author ID. On the the author ID that is present in the books table should be the same as the ID on the author's table. So books dot author ID is equal to authors dot ID. But we don't want all the books for each author. We want only the ones that are written by Victor Hugo. So we should filter by a where clause. The, the last name of the author should be Hugo, and the first name should be Victor. Yes, last name uh, Hugo, and first name is equal to Victor. And we press enter. Now we can get all how we can see that the that Victor Hugo wrote a book named Les Misérables. Is the only book we have in our database written by Victor Hugo, Les Misérables in this case. The next question will be to count the number of books for each genre. So we should display for each genre, we should count the number of books that belongs to this genre. So we are going to use for this question the table books and select the genre and count for each genre the number of books for this genre. So we can do count étoile as we can name the results of of count star as for example count book from books, and then we should absolutely group by each genre because for each genre we should count the number of books. That's why we are going to use the group by statement. Now we execute, and now we have the number of books that belongs to each genre. Now for the question number nine, not number eight, sorry, we should display the titles of books that have been borrowed. So the books that are present in the table loans. So we should select title from books where the ID of the books is present is mentioned in the loans table, which means it's in the the total of the book's ID in the loans table. So select uh, select book ID from loans. Execute. Now we have Pride and Prejudice, The Hobbit, etc. Those are the books that are borrowed. Passing to the ninth question, yes. The question says, display the names of borrowers and the titles of the books they borrowed. So, for each each borrower, each name of a borrower, we should display the title of the books of or all the data of the books that they borrowed. So, to summarize the data we need the books, the information of the books. that have been borrowed. To know if the book is borrowed or not, we should use the table loans. That's where we know if a book has been borrowed or not. And finally, we needed the table borrowers to know the people that borrowed the books. So select borrowers dot last name, borrowers dot first name to know the information of the borrowers, and of course the title of the books. Books dot title from loans, because it's not just simple information. It's These are the books that have been borrowed. So these the books that are present in the table loans. Join borrowers on loans dot borrower ID equal to borrowers dot borrower ID. As you can see here, we needed three tables. So we did three joins, three different joins, because we needed three tables to extract all the information. The tables we needed are loans, borrowers, and books. Yes, join books on loans dot book ID, the books that are present in loans, equal to books dot ID. So to summarize, we needed borrowers, the people that borrowed the books, the information of the books and the loans to know the books that have been borrowed. The books that are present in loans are the books that have been borrowed, and the borrowers that are in the loans, the ID of the borrowers that are in loans are the borrowers that borrowed the books. So now we have exactly the result we needed. For the question number 10, we should calculate the average duration of loans. So to do that, the information we need to calculate this duration are in the table loans. So we should select the difference between the return dates and the loan dates and calculate the average of this difference. So for that, we will select the average, predefine the function in SQL, average, and the difference between the return dates and the loan dates. Because the return dates and the loan dates are not uh, don't have the are not integers, we can't do the minus operation directly in the query. So for that, we should use predefined function in SQL, which is the date diff for return dates and loan dates. This function performs the minus the difference between two dates and returns the results as a days or as a duration of time. So we just one detail: the return date should not be null, because if it is null, we can't perform the date difference function can't perform the operation. The ones that have returned date null are the ones who didn't return the books yet. So to execute this query, we should only use the borrowers and that's returned their books. We execute the query and we have the result 14.5 days. So the average duration of loans is 14.5. So for the question number 11, we should display the titles of books that have never been borrowed. Uh, in our case, we have the table loans that contains the data of the books that have been borrowed. But in our case, we want to obtain the books that have never been borrowed, so the opposite of this query. So to make it simple, we want the books that are not present in their information are not present in the table loans. These are the books that have never been borrowed. So we should select the title from books, from the table books, because it's the table where we have the title of the book from books, but the title the 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 identifier of the book should not be present in the identifiers that are present in the loans table. So where ID not in select star from select book ID, sorry, from the loans table. Execute, and now we have all the titles of the books that have never been borrowed. If we want all the information of the books that have never been borrowed, we should replace title by star to select all the information. And now we have all the information, the author ID, the publication year, the genre, etc. But we will use just title according to the response of our question. For the question number 12, we should display the current loans, the books that are not yet returned, with the names of the borrowers, which means the borrowers that they didn't return the books yet, and the titles of these books that aren't returned yet. So we the books that are not returned yet are the books that has that have the return dates null. To analyze this question, we should use the table loans to get the the books that are not returned, the names of the borrowers, which means the table borrowers, to get all the information of the borrowers, and the table books to get also the titles of the books. So we have three tables to use, which means three joins. So we should select the current loans, the names of the borrowers. So the borrowers dot last name and the borrowers dot first name. Borrowers dot last name. Borrowers dot first name and the titles of the books. So books dot titles from loans, from loans or from books, from we could start from with any table we want. I will start with the loans table from loans. Jo join the borrowers table because it's the table where we get the borrower's information on the loans. I guess let me check. The loans dot yes borrower ID is equal to borrowers dot borrower dot ID. So it's equal to uh, borrowers. Yes, borrowers dot ID. Borrowers dot ID. And we should not forget the books table because we should get all the book's information. So we should add another join books on loans.book ID equal to books.id. But to not forget, we should add a condition here, a where clause, to specify that we want the books that are not yet returned, which means the books that have the return dates equal to null. It's null. We don't have an information there. So where the loans dot return dates is null. Where the loans executes, I mistyped the borrower's dot first name. We check it, and now we will have the query that give us the final results. The so these are the people that borrowed books and they didn't return it yet. So you can call the library can call them, for example, and contact them to get the books returned to them. The last question in this practical case will be to display the three most borrowed books. So for this question, we will be needing the table books to get the information of the books, and to know if the books are borrowed or not, we should use the loans table. So we need in this case two tables, the books and the loans, which means that we will have to perform a join between these two tables. And to know whether they are borrowed and how many times these books are borrowed, we should count how many times the identifier of a book is repeated. So we should count the loans dot book ID from loans, and we should join it with the books table because we want all the information of the books on the loans dot book ID equal to books.id. Uh, so we should group by, of course, we should group by to count each identifier. We should count the number of times this identifier is repeated. So we should group by the identifier of the book, and to know the three most borrowed books. This means that the identifier that is repeated the more, and to be able to know that, we have the count loans that's book ID, the count of the repetition of the book ID. This measure is the one that will make us count the three most borrowed books. So for this for this discounts, we will use the count loans.book ID. I will name it so that I can use it in the order by clause. I will name it, for example, as for example, loan book, as loan. Yes, loan book is good. Loan book, and loan count, and then and we should order by this loan count, but we should specify that we want this order to be from the maximum to the min to from max to min, because if we don't specify it in the order by clause, we know that the order by the default the default the default sorting will be from min to max. But because we want the top three most borrowed, so we want the max to the min, so we should use the descending sorting sorting from the order by, and we should select only the top three borrowed, so we should only select the top three rows, which means limits 3 to get only the three first rows. So with this query, we mark the end of this video, which was a practical case of SQL and is the final video of our SQL training series. We had articles about going from basics in SQL, selecting, filtering, grouping, sorting, etc. in SQL in our page Data Insights on LinkedIn, and go into the practical case to get to know how SQL is really used in the real time real life problems. I hope this video was very clear for you, and please don't hesitate to reach out to Data Insights team, to Data Insights page, to ask us if you have any question on this video or anything else. And I thank you so much for keeping up with us. Thank you.